Okay, so today I want us to discuss classification of data. I want us to briefly go through it. I believe we have already covered this, so it's just a summary. So like we said, classification of data, this is basically the act of arranging the data. You're arranging the data in either groups or classes according to some shared characteristics. Yeah, so in this case, we have two types of data classification, not two, but four types of classification of data. There is qualitative. So in this case, you classify according to the attributes or quality. In this case, the attributes, they can be in terms of, so in this case here, we have gender, that is sex. A person can either be female or male. The literacy, or in simple term, we can say education level, where a person can be maybe dropped after primary, secondary school, after a diploma, a degree, masters, and so on. So you're trying to find the level of education of a person. Religion, a person can be a Muslim, can be a Christian, can be a Hindu, and so on. So that is quality. Those are the attributes of that person. So in that case, you can classify all the respondents with those attributes. Then the other one is quantitative, whereby you are classifying according to some characteristics that can be measured. Something that can be measured: a person's height, a person's weight, a person's age. It can even be BMI, and so on. It can be the number of children. So in this case, this is something that can be measured. Then we have the temporal classification according to time. So in this case, you can see some data which is classified according to time, like a specific month, like you have the sales for a specific month, and so on. You can have the production of a certain product for a specific month only, or a year, or in terms of weeks, and so on. Yeah. Then we have the spatial. That is the classification according to place. In this case, it can be depending with where a certain product is produced. For example, we have specific area whereby you can only find tea. For example, in Kericho, Limuru, that is in Kiambu, and so on. Even in Kirinyaga County, you can as well find. So you can see production of tea in Kirinyaga. You can see production of coffee in Moranga, and so on. Yeah, so that is the classification of data. After classification of data, you move on to tabulation. You move on to tabulation of data, whereby now you come up with data you arrange your data in columns and rows. In this case, you are forming a table. So we have discussed how you come up with a table, but we have two types of table. It can be simple table or complex table. So in this case, a simple table, it only contains, as in the data is in respect to one characteristic. For example, whereby you just find the data, you can see time only and the produce. For example, time and sales. For example, 2010 sales yake, 2011 its own sales. Are you getting? If it's in a business setup. So if it is in a farm, let's say someone who is producing coffee, you can see the production of coffee for January, it is this one. For February, it is this one, for the whole of that year. So that's a simple table with only one characteristic. If it's sale, it's sale. If it is production of coffee, as in if it's produce, it is that one. Then we have a complex table whereby you can see table figures relating to several characteristics. And this is what we prepared actually. Whereby we were converting data into a tabular form. A table has its own advantages. One, tabulated data can be understood easily as compared to data given in narrative form, as in where you change the picture of information, you summarize it in a table, and you make it more understood, as in easily understood, or it can be even easily be subjected to future differences. So the unnecessary data is avoided. You remove most of the information that is unnecessary. You only concentrate on what can make a change later on. Then the tabulated data take less space. Then, okay, those are just a few of the advantages of table or tabulation. Then we have the key things that you're supposed to ensure that it is clear in your table. For example, the table should be self-explanatory and easy to understand. Each table should have a title. Ensure that your table's got a title. Then the size of the table should be suitable, not too large, as in it should make data very simple. The source of data should also be stated. The heading to the columns and the rows should be clear, and so on. I believe you went through these principles one by one, and as I saw Firdosa, you were able to come up with a very good table. So here we had a question. This is just, I just wrote the question. I never included the interpretation, but there was a table there. I hope you can tell how this information was interpreted to a point whereby I was able to come up with this table. So remember, our question on our assignment, you were supposed to interpret on your own, and that was clearly described in the video. There was a video on a tabulated data. So in that case, that made it very easy. So ensure this example you can be able to interpret it and come up with a similar table. In this case, we have a title at the top here. We have a title. Then down here we have the source. So also your table should always have a title and a source at the end of it all. Then briefly, let us go through something else. A variable. What is a variable? Firdosa, there is some background noises. Okay. So in this case, a variable, this is a measurable quantity which varies from one value to another. And so basically a variable is what we are talking about. For example, when you're talking about age of a person, that's a variable. It's something that changed from one person to another. Weight and so on. The number of children in a household, you find that it's something that varies in a household. So variables, they are classified into two main types. And in this case, we have a discrete variable and a continuous variable. So a discrete variable is a variable which can assume only the whole numbers. So those variables that only take the whole numbers, these variables, they have exact value. For example, the number of children in a house, the number of houses in a village, the number of books in a journal. These are just a few examples, but basically, you cannot say in a library, we have 5.5 journals. That's as in, no one can understand, okay, there is nothing like a half journal, and so on. There is nothing like a half a child or a quarter a child, and so on. So in this case, these are things that can only be expressed in whole numbers. They have exact values, no decimals, no fractions. Then we have continuous variables. This can assume any value, as in the variables change continuously. So in this case, for example, the height of a person can be 150 centimeters. Another one can be 150 point something, as in like 0.2. Same case with weight of a person. A person can be 50 kgs. Another one can be 50.2, 50.3. As in we have different values in a specific range. It takes into account values with fractions and decimals. Then our key area of today, I wanted us to go through frequency distribution. And so now this is also another form of a table. It's still on a tabulation of data. So frequency distribution, this is so now we want to arrange our data in a more, like, basically in a table that is very common in statistical work. A table that can be subjected to other statistical processes, such as in it can be used in the formation of graphs, it can be used in calculation of averages, it can be used in calculation of median, it can be used in calculation of mean, the measures of central tendency, the measures of dispersion. All of them can be calculated from a frequency distribution table. So this is a very critical table in statistics. So the construction of a frequency distribution involves the following steps. The first step, you need to decide on the number of classes. Then you decide on the class interval. So the class interval, then the class limit, and the frequency in each class. So in this case, this is well described, well interpreted in a video. And I believe that you have gone through that video. So I want to go an extra, okay. The two forms of grouping you have gone through, as in it was interpreted in the video. That is right, Firdosa, right? Yeah. Firdosa, did you understand the difference between inclusive form of grouping and exclusive form of grouping?
Yeah, I've understood.
You've understood. Hoping you made some summary notes on your book from that video. Okay, okay. So if
Yeah.
that was well understood, I want to go an extra mile on our table. I have a few questions. The first question, this is on our assignment. I will check to see whether you did the correct thing. I also had another question. Can you be able to see my question number 2 here? Or it's not clear?
Not clear.
It is not clear.
Mm.
Okay, from this question, okay, if you check our first question, the one which is on our assignment, our question was only asking us to make a frequency distribution table starting with a class interval of 5 to 9. So in this case, you are the one who was deciding whether to use inclusive form of grouping or exclusive form of grouping. But if you check our second question here, let me just read for you if you cannot be able, it's not visible. I will try to come up with a clear photo. So our question is saying, you construct a frequency table using the class interval of 6, starting with 2 to 7. So what does that mean? Have you, not somewhere, a class interval of 6 and starting with a class of 2 to 7. So in this case, we have a class interval of 6 and we have been given our class interval S, our classes, our first classes 2 to 7. So in this case, you try to ask yourself, is this inclusive or exclusive? Okay, we'll be guided by our class. Our first class is 2 to 7. If you get 7 minus 2, that will give you, 7 minus 2 is, Ferdosa?
5.
It is 5. So in this case, remember our class interval is supposed to be 6. So this must be inclusive form of grouping. It is inclusive because when you try to use the whatever you get, the class, our starting class is supposed to be 2 to 7, such that if you use the class limits, for example, if you want to get 6, you need to get 7.5 minus 0.5. Are you getting that language?
Mm.
Yes. So if you minus 7.5 minus 0.5, not 0.5, sorry, 1.5. The limits for 2. The limits for 2 is 1.5 and 2.5. So the lower one is 1.5. For 7, the higher one is 7.5. So 7.5 minus 1.5, that will definitely give you 6. That is right. Cindy?
Mm.
Yes. So meaning, in this case, you're supposed to use inclusive form of grouping. So you have first to understand that, then you go to come up with the other classes. So in this case, if it is inclusive, if our first class is supposed to be 2 to 7, it means that the next class is supposed to be 8. It will start with 8 since it is inclusive form. So it will start from 8 to, you get 8 plus, you add 5. You don't add 6, you add 5. Such that, so 8 plus 5, that will give you 13. Such that if you want to find the class interval, you have 13 and 8. So in this case, it's you get the limits. The limits here are 13.5 minus 8.5. That will give, not 8.5, but 7.5. That will give you 6. Hoping you can differentiate that. Are we together? Yes.
Yeah.
Then after you, I believe from there now you can be able to come up with a table. You come up with a tally and frequency. And then we see in this question, there is a part 2, which is asking you to construct a relative frequency table as a percentage. So that is an area that I want us to make it very clear. A relative frequency table in percentage. That means after you have your table with classes, tally, frequency, you need to add another column for relative frequency first. Are you getting that? As in, you're supposed to add another column for relative frequency, as in on the same table. You don't draw another table. You use the similar table. So you come up with a relative frequency percentage. How do you do that? For relative frequency, you're supposed to get, you already have your frequency. Now you want to find the relative frequency part. So for relative frequency, what you do, you're supposed to get, for example, let's say the frequency of the first class, 2 to 7, is let's say there are 2. Are we together? So let's say there are 2, but the data, for example, the data that is here we have the total frequency as 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. That means the total frequency here is 30. Are we together? So if the total frequency is 30, hoping you are noting somewhere, Ferdosa, if the total frequency is 30, then if the total frequency is 30, then your first class got 2 as the frequency. So for you to find the relative frequency, it is supposed to be 2 divided by 30. Are we together?
Yeah.
Let us use a figure that is divisible. Eh? So let's say our first class got 3 as a frequency. That is, you counted the number that can fall between 2 to 7, they are 3. Are we together? They are 3. So, and our total frequency is 30. So for you to find the relative frequency, you're supposed to get 3 divided by 30. That will give you, 3 divided by 30 is, it is 0.1.
Mm.
Are we together?
Yeah.
Firdosa?
Yes, madam, I'm following.
Okay, so 3 divided by 30 is? It is 0.1, Firdosa. So 3 divided by that is 0.1. You must have a calculator, by the way, if you want to progress well with statistics. So, okay, this question I will do this. I will come up with a, I don't know. Okay, I'll take a clear photo, then I will post it on our e-learning platform so that you can be able to see what I'm trying to explain. So we have 3 divided by 30, that is 0.1. If you want to convert that to percentage, what do? You multiply by 100. Are we together? So that will give you 0.1 times 100 is, it is 10. So that will give you 10 as our first relative frequency in percentage. Okay, I will try to do it on a paper, and then I will take a photo and post it. You'll be able to see what I mean. Then the other one is the other question. So you're supposed to do that for all the frequency. You get, if the second frequency is, let's say 5, you get 5 divided by 30, then you multiply by 100. You go listing them. Then the other question is asking to construct a cumulative relative frequency table in percentage. Cumulative relative frequency. Cumulative. So this is another term. It is cumulative. So you see what you got on the relative frequency column in percentage. You're supposed to go adding them. I will explain that very clearly. Don't worry about that. Then from that, on the same question, you're supposed to draw a cumulative frequency histogram. Now this is the graph work, but this will be discussed on our next topic. So basically, that is what I wanted us to discuss, Firdosa. Let me check on your assignment and see whether you did the correct thing. Then I will post this second question. I don't know whether we had another question here. I had 3 questions. Yes. Okay. Is this question clear? Can you be able to see that question? Firdosa? You can
Yes,
see the
but
third question,
not
yes?
clear well.
It is clear.
Mm.
Yes. Okay. So you see this question now, we have data here. This is not a table, as in this is just raw data, which is put, as in it was like constructed in a form of a table to make it easier for you. But this is a raw data. We need to prepare a cumulative frequency distribution table from the data using a class interval of 10 and applying inclusive method. You see, this one is specifying. So our class interval is 10, and the method which we are supposed to apply is inclusive method. So in this case, what does it mean? Let me admit Sarah, but she's very late. She's very late. We are almost winding up. Okay, so let us just continue. So in this case, in our third question here, we are preparing a cumulative frequency distribution table. The data for the data using a class interval of 10. So the class interval is 10. So remember, from any data, any question first, you're supposed first to identify the maximum and the minimum value, right? So in this case, if we try to find the maximum here is, so we have 186, we have 202, which is the maximum? I think the maximum is 202. Yes, maximum is 202. The minimum is, we have 126. Is there a figure which is less than 126 here? I think the least figure here we have is 126, and the maximum is 146. No, not 146, but 202. Yes, that is correct. So meaning, if we want to use inclusive method, and our first figure is 126, and our class interval is 10. Firdosa, which will be our first
Yes,
class?
madam.
So our first class will be from 126 to
126 to
126 to okay, let me help you. If you're about to say it will be 126 to 136, as in whereby you just add 10. Are you getting? If you add 10, that will, if you get 126 plus 10, that will give you 136, right? But remember, the question have specified we are supposed to use inclusive method. So if we say it, the other one will be 136, that, as in the picture that will give us, that will give us a picture of exclusive method. So in this case, it's supposed to be 126 to 135, such that the next class will start from 136 to 145. Are we together? Such that in this case, from 126 to 135. Okay, there is a lot of noise. I don't know whether it is Sarah. So 126 to 35 to 135, if you want to find the class interval, you're supposed to use the limit such that you'll use 135.5 minus 125.5. That difference will give you 10 as a class interval. First understand that. Then, so after you come up with your classes, you come up with the tally, you come up with the frequency. Then you need now to add another column. You need now to add another column for frequency, no, cumulative frequency. How do you find the cumulative frequency? That is the next thing that you need to understand. So the cumulative frequency is, you're supposed to go adding the frequency. So like you start with the first class. If your first class is 126 to 135, then you find that the frequency is 3. Then the next class is 135 to 136 to 145. Then let's say, for example, the frequency is 5. So on the cumulative frequency column, the first one will be 3 for the first class. Then the second one will be 3 plus 5, which is 8. So that is something that I need to explain well for you to understand, Firdosa. Sarah, how are you, Sarah?
I'm fine.
You have joined our class very late.
I'm good.
You have joined our class very late. Actually, we are winding up. Ensure that in the next Zoom class you join very early. Also, I need you to submit the assignment. You submit the assignments from the first one to the second one. The first one was on tabular form. The other one was on a frequency distribution. So ensure that you submit those assignments. I'm about to check what Firdosa did on the frequency distribution. And then on the frequency distribution, I will add something small so that you can understand about relative frequency and cumulative frequency. Are we together, Firdosa?
Yes, madam.
Yes. That's it for today. You can have a good day.
Okay.